All right, so you guys should all hopefully be aware today we're covering roller mill, roll crusher maintenance and operation. The main goals we're going to try to get through today is hopefully we're going to try to reduce your downtime that you guys are seeing in your facilities. We're here to help protect your investment, hopefully improve your efficiency, and even help you potentially produce a higher quality end product. In easy terms, we're hoping to create less headaches for you and increase your profit, which I'm sure everyone would appreciate. So most of the machines that we have out there and what you guys are all looking at is probably one of these four, either our 650, 900, 1200, or 1600 series. Some of you may have our 1000 or 1400 series. Those aren't as popular, but we should see most of everything I'm going to cover today will be applicable to everyone. I'm trying to paint with a pretty broad brush. Just for everyone to keep in mind, there's a wide variety of people listening today that many of you are grinding vastly different products. So I'm going to try to keep it pretty vague. As always, if you do have any questions that is specific to your product, you are always welcome to reach out to us. But that being said, the majority of the people listening today are grinding corn. So if I do use examples, I may lean that way. So please don't feel slighted if I'm not including your product. But again, all the principles should be applicable to your application here. And just real quick, on top of those, the series that I just showed, these are the widths of those machines. Again, pretty much everyone that's on here, you should fall within the range that you're seeing of these options available. Now, just real quick, on the nomenclature that we use for our machines, many of you may be aware of what exactly your machine's called, you might not, but just real quick, I'm gonna talk a little bit about how we call them and why we call them that. The first couple letters, 2 or 3 letters you see on your machine will actually tell us the number of rolls, whether it's a SP, DP, TP, or even then a TRC, FRC, or SRC. That's going to indicate the number of rolls that you have in your machine. The next couple letters is the machine series, and that may not mean as much to you guys, but internally that tells us quite a bit of how your machine is configured. Again, it doesn't mean as much to you, but it does help us internally. And then the numbers at the end are really going to talk about the size of your rolls. So a 1200, like I'm showing here, tells us that we have a 12-inch diameter roll. So some of you may see if you have a 6.5 diameter, it's our 650, and then there's the 900/999. Those are both a 9-inch roll, or that could be the 1000, 1400, or 1600. Again, that's just going to indicate our roll diameter, and then the number at the end after the dash is going to tell you the roll width. So in this case, we have this machine is telling me I have a double pair machine that has rolls that are 12 inches in diameter and 36 inches long. So just to really quickly go over the nomenclature of what your machine may be called and what those numbers and letters actually mean. Now, before we jump into it, just need to cover this, and I'm hopefully all you guys are practicing this, but please always make sure before you open up your machine that you are properly locking, tagging out, and de-energizing it before you get into it. So today, these are going to be all the variables that we're going to go through that kind of show how we can affect the performance of your roll crusher. No need to write these all down because you will get a copy of this webinar, and also this slide will appear many times going forward. So jumping into it right away, number one is going to be the number of rolls. And some of these I'll say might be a little elementary and obvious, so we won't dig too deep, but I do want to touch on them. So number of rolls you have in your machine. If you're looking for a relatively coarse grind, you may only have 2 rolls. If you have a grind where you're trying to get pretty fine, you may have 6 rolls. So again, that's pretty obvious. And then with the 4 roll in there, you're kind of in the middle. You need a medium grind, if you will. And for the most part, if you have that, you're actually not stuck. If you have a 2 roll or a 4 roll and you wish you had a 4 or a 6 respectively, it is actually possible to move up the amount of rolls you have. One way we can actually do that is what we call our flat top conversion. It's simply, with this example I'm showing, we have, let me get my laser over here. You can see this is a double pair. We have 4 rolls in this machine. This particular place was hoping to get a little finer grind and increase their capacity a little. So actually all we had to do was lift the machine up and add a single set of rolls on the bottom. So we were able to convert this 4 roll into a 6 roll machine. So again, just again pointing out that you are not fixed with the number of rolls you have. It is a relatively low cost way to increase your production or change your grind without having to buy a completely brand new machine. So there are a few options out there if that's something you guys may have interest in. I'm going to jump over to the roll diameter real quick. Again, this is a variable that most of you guys have not changed because the rolls are pretty fixed that you have in your machine. But the reason I want to bring it up is to show what the different roll diameters can do. And the biggest thing with the roll diameter is the larger diameter you get is going to come with some more advantages. And the biggest one is you have a more optimal nip angle as compared to a smaller diameter. And what that nip angle does is it helps actually grab that particle or the product that you're trying to grind and pull it down into the rolls to be ground, as compared to a smaller roll, which takes a little more energy to try to pull that product in. So we'll see if you have the same width roll, but a slightly larger diameter, we do see a more efficient grind with the larger diameter roll. So if you're looking at a new project, that's something to keep in mind when you're looking at what machine you want to get. Is a lot of times we'll try to bump you up to a larger diameter just because it is a more efficient machine. A real easy way to think about that efficiency is the example I show on the bottom right. Is if you have to jump a curb, a truck with full-size truck tires will be a lot easier to jump over that curb as compared to the golf cart shown there with a smaller diameter tire. And another thing that I do want to point out is actually the roll deflection. I know it's hard to see with a naked eye, but those rolls do flex and move under the pressure of the product. And the larger diameter roll it has more strength to it and is not as forgiving and will not move as much. So you actually will see a little more of a homogeneous grind just because those rolls are not deflecting as much. And one of the other nice things that comes into play with the diameter is actually you have more surface area. So you can imagine a 12-inch roll compared to a 16-inch roll, there's a lot more surface area on that 16-inch roll. And the benefit that brings is because you have more working surface area, you are able to go longer in between your corrugations. If you actually compare, your tons per surface area, it'll be the same, but you have more surface area, so you don't have to recorrugate your rolls as much, which will save you some downtime. And similar to what we just talked about with potentially changing your machine from a 4-roll to a 6-roll, we actually can convert some of your roll sizes to a larger size while maintaining the same frame that you're running. I don't want this to be a sales presentation at all, but I just want to let you know of some of the options we do have available because it can improve your grind. This is not an option that's available for everyone, but some of you that are running either a 12-inch or a 14-inch machine, we do have an option we can look at. And with the 12-inch, we can upgrade those rolls to be 13 3/4 inches in diameter. And with some of our 14-inch machines, we can upgrade those to be a 16-inch. And like I said, we maintain the same frame. Typically, we just have to look at some of the drive components to change. And just like I mentioned, the benefits you get there are that nip angle is going to improve. We'll see a slightly better throughput because you're more efficient. You'll also see longer time between corrugations because you do have more surface area. So you can save some downtime, save some maintenance costs as well. And one quick thing you can see I show on the bottom, we do want to make sure if you are getting a quote on some 1375 rolls, do be careful, do your homework and due diligence, because there are some non-OEM companies out there that will take a 14-inch roll and lathe it down to 13 3/4. So they're removing a 1/4 inch of usable roll from that diameter, which will greatly shorten the usable life of that roll because you've wasted a lot of the good part of the roll. Now to talk real quickly on roll speeds and roll differentials, because that is another factor that comes into play, is how fast your rolls are spinning in there. I'm guessing for the most part, most of you probably have not done much investigation into the way they're spinning and why they're spinning. But in our machines, our typical setup is to have our mower either in the C position here, or you could have it in the Z flow, which would be sitting over here. But our front roll is our fast roll, as we call it, and that front roll is driven by the main drive belts off of the motor. And then our back roll is what we consider the slow roll, is driven by the IRD belts or inter-roll drive. is shown on this side of the machine. So our back rolls are driven by the front rolls, and the front roll is driven by the motor. And we call them the fast and the slow roll because this differential, typically, depending on the differential we use, will run this roll at a slightly slower speed. And we do that because we get, depending on the differential we use, we get more of a shearing action inside the rolls instead of a crushing or smashing action. That shearing action gives us more control over the grind. So typically we'll see a tighter standard deviation, a little more homogeneous, so not as many fines and not as many overs. Depending on your application, again, I want to paint with a broad brush here, is that there may be some of you, if you're just in a simple cracking application or very coarse grind, you might be running a 1-to-1. But some of you, if you're in more of a dehulling application, you might be in a 2-to-1. So we do have a few different options in there. It is something, depending if your grind has changed and we're trying to accomplish something else from your machine, we may look at changing that differential. But just to know that's an option there, and that is how your machine is set up, is that those, for that front and the back roll, are spinning at a different speed. And again, something to keep in mind is if you may see a difference in wear, is the rolls that's spinning faster, it may see a higher wear, especially if you have a higher differential, you might cause it increase the wear in those rolls. Now, just real quick to talk about the IRDs and the idlers shown on there. Quick show of hands, do any of you have the setup shown on the left with that third idler? So it looks like there's a fair amount of you. If you do have this setup, we've actually changed our design recently, because you can see on the picture on the left, there is quite a bit of belt wrap around that shiv. You can see right here. And we don't actually need that much belt wrap to accomplish to make sure that roll's still spinning. We have enough contacts shown here on the right. So if any of you do have this third idler and you feel like you're seeing some higher temperatures shown on that side, or potentially even some premature belt breakage, a very simple fix we can do is actually change your belt wrap, and we don't need to use this idler anymore. So any of you out there that do have this third idler, please feel free to reach out to us. We'd love to help you, potentially save you some nuisance trippages or also some belts. So please reach out. Happy to help you with that. Now, to talk about corrugations as well as roll condition a little bit. So we select our corrugations, the profile we want to use, as well as the grooves per inch based on the application as it comes through the sales process. So to ask you guys, has your incoming product changed? Has your desired finished product changed at all? We may want to review the corrugations you're using. We hear it quite a bit that someone calls in, wants new corrugations, and they just say, well, just get us what we did last time, and that could go on for 5, 10, 20 years. And if we ask, well, why do you want that one, and they tell us, well, that's just what we've always done. And I get there's some merit to that, but sometimes that tribal knowledge can inhibit your grind. So please utilize our applications teams. That's what we're here for. That's part of the service we offer when you do business with Roskamp. So a quick question of, hey, is this the best for my grind? This is what I'm doing. Could be a 5 or 10 minute chat with our applications team. There's a good chance the majority of the time we might say, nope, you got the right ones, let's keep going. But there's a good chance there might be a new technology out there that might be better for your system, could improve your efficiency, get you a better finished product, help you increase your profits. So please utilize our applications team. And like I just said, there could be a new technology out there. So if you're not reaching out to talk to us and hear what the latest and greatest is, many of you might not know about our new blue roll technology. Some testing we've done, can't go into a lot of the specifics and technical details, but it's a technology that we can extend the corrugation life of the rolls. For a lot of our applications, and I talked right here about cracking soybeans and grinding corn, but we've seen the corrugations last 2 to 3 times as compared to our quote unquote normal rolls. So if any of you are interested in extending the life of your corrugations and reducing your downtime and saving a little money, again, please feel free to reach out to us. I don't want to get too much into it. Again, this is not a sales presentation, but it's a technology that is out there and can help improve your process. Now, in regards to roll wear and the condition of your rolls, when you guys open up your machine, are you inspecting them very much? It'd be ideal if you could, really look at the front rolls, look at the back rolls, if you're able to rotate the rolls a little bit and really inspect them and see if anything looks abnormal. That's the biggest thing I really want people to take away is every time you have that machine open, do look for anything that looks out of the ordinary, something abnormal that you could prevent some really headaches down the road if you notice them early. So some of the reasons you might see some abnormal wear in your rolls. First and foremost, could be as easy as those rolls aren't in parallel. You might be feeding them unevenly. You could have sent a lot of oversized material or foreign material, or even we've seen it where some non-OEM recorrugating services didn't do as quality of a job as they should have. So keep an eye out for anything that looks abnormal. If you're not able to tell what it is, please get us involved. We're happy to help. The corrugation process of the rolls is not a cheap thing. So we want to make sure we're able to get you the most value you can out of those rolls. Another thing to keep an eye on is damage. And not only that is if you're seeing premature wear. These rolls are designed to grind your product and only your product. For your corn guys, the more cobs and stalks and rocks you throw in there, the faster those rolls are going to wear and you're going to see some damage. So I always say, a grain scalper ahead of your process will pay for itself. It's worth its weight in gold to keep a lot of that foreign material out, just because cobs are such an abrasive thing, or even some of the stalks and hulls and anything else that we don't want to have in that machine will increase the wear of those rolls. And just a quick example to show on this roll, you can see a nice little dent in those corrugations. Well, every time this roll turns, there's just a little pocket right there where the material is not going to get ground. That doesn't seem like a whole lot, but if you have one like this, you might add 2, 3, 4 more. If you keep letting bolts go through your process to where now you have a bunch of little pockets all over your roll, that's allowing larger products to get through, which is going to make a less homogeneous grind. You might see a higher standard deviation. So keep an eye on those rolls. Like I said, every time you open up, look for something abnormal. Again, there's just another example of some damage we've seen. You can see it looks like they got some, possibly some ball bearings or some bolts or rocks in there. And then as well as they had their cheek plates here on the side overly tightened, which wore a groove into that roll as well. Now the next three things I'm kind of I'll talk about at the same time just because they're all very closely related, but that's the roll gap, roll parallel, and even the roll tram. The parallel, I hope, is pretty self-explanatory to most of you, but I do want to bring it over, talk about it. It is very important to check. It's really easy to check when you got that machine open and you're doing your PMs. Everyone should have gotten a feeler gauge when you bought our machine. For those of you that are running a machine that's still running after 30, 40 years, I get that feeler gauge might have been lost or broken or worn. A really easy thing I've seen people do is you can take a couple pieces of banding strap, as long as they're the same thickness, and you can use them on either end of the rolls just to help maintain and make sure those rolls are parallel. Just because, as you can imagine, if you have a situation like shown on the bottom right, what you're going to do is you're going to see a couple things where you're going to make a much finer grind over here on the right side as compared to the left side where you have a much coarser grind. So then you're going to have a higher standard deviation, not as homogeneous of a grind. But on top of that, you're going to wear these rolls evenly. This right side over here is going to wear much faster than the left side. So then once you do correct the issue, depending on how long you let it go, those rolls may need to be replaced. While the corrugations on this side may still be in good shape, on the right side they're worn, and again, you didn't get the full value out of those rolls. So trying to make sure every time you open up that machine, just keep an eye out, look for some of those abnormal wears. Now the roll tram is something, again, that's not talked about as much, and for the most part you really just need to pay attention to it when you're installing those rolls, but we do want to make sure the rolls are in tram. I'll talk about here in a couple slides where that adjustment is and how to adjust it, but it is just as important as the roll parallel. And so to adjust the parallel on our 1200 or I'm sorry, the 1000 or larger machines, it is very simple. On the back of the machine, there's this coupling that connects the two jacks together. Because it is a single point roll adjust, we can actually make it so it is dual point. You simply uncouple it. You can move either the right side or the left side as you need. You can get those rolls parallel. It only takes a couple minutes. For those of you that may be operating the 900 series, I understand that it's going to take a little bit more than a couple minutes. So I apologize there, but I will show you how to do that process in just a few moments. You can see the couplings here on this picture. Hopefully most of you are familiar with the hand wheel that we're opening and closing the rolls. Again, I understand some of you may have a full feature, which is pneumatically driven or driven with an electric motor, but you can see where those couplings are located. Grab my laser again. They're shown right here. So we can decouple it and we can either move this jack or we can spin this shaft to move the jack on the other side to get those rolls into the position we want. Another way to check parallel, and is a great PM to do, is actually to be pulling a sample from the far right and the far left side of your machine. I know most of you probably just grab a sample per shift, and that's okay, but every so often it would be a really good idea to not only pull a sample from the far left side and the far right side, but to even pull one from every bank of rolls you have. Now, if you only have a single pair, obviously you only have one set of rolls, but especially if some of you get into that wider machine. The wider the machine gets, the more difficult it is to maintain a parallel, which is actually one of the reasons we would not designate our 72 or 84 inch wide machines to be used as a grinder, just because it is very difficult to maintain a parallel on that wide of a roll. And not only that, you do get the roll deflection in there, which is going to inhibit that as well. But the wider your machine is, just every so often you can pull a sample, like I said, from the left and the right side, and even just visually inspect. The longer you're running, the more you'll be able to tell if something looks out of place and if that needs to be adjusted. So don't have to do it every shift, but it would be a smart idea every so often to pull a sample from each side of the roll. It's an easy way to do it without having to turn off the machine, lock it out, and open it up. And hopefully all of you are familiar with the sample scoop shown on the bottom of the screen. Everyone should have gotten one when your machine shipped. I get it, they go missing, things happen to them. So if you need one, again, reach out, we can hook you up with one. Now, cheek plates and roll seals. This is a very important one. It's one of the more common things I find when I'm out visiting your guys' facilities. It is something that's overlooked and not known. So the cheek plates are the UHMW plate you see up here at the top, the white sheet. And what this piece is functioned to do is to prevent material from going around the outside of the rolls. We want to make sure all the product you're grinding has to go down through the rolls and be ground. So this plate is adjustable. It's slotted, as you can see. So as the rolls wear, we can move them as well. But you can see there's just a very tiny gap between the rolls and that cheek plate, because hopefully we don't want them contacting, because it will create wear. And if you really shove them down in them, you can see that abnormal wear like you saw a few slides ago. But you do want to make sure you have a pretty tight seal that's in here. Again, after you've done a few recorrugations, you've lost some diameter. We do have different cheek plates that will conform to that different size roll. So it's possible if you've recorrugated your rolls a handful of times, we may need to look at using a different cheek plate in there. And then the roll seal that I mentioned is shown here on the right and the left of the rolls. Let me get my laser back. It's this plate. You can see the ledge right on it on the right and the left, and it's also shown over here in the purple. Now what that seal is it's slotted, if any of you are able to look close enough and see here, that it can slide up and down. And that is used to prevent material from going over the tops of the rolls. Again, everything that we're putting into the machine, we would like to grind, so we want it to go through the rolls and not around them. So this is slotted, like I said, so it can go up and down to conform closer to the roll. Again, you want to get it as close to that roll as you can without having it come into contact with the rolls and the corrugations. If you do it, you'll know really quickly that if you do have contact there. But doing that, again, will prevent larger material from going over. So if you're seeing your grind, you're seeing a lot of overs from what you want, this is a couple great places to check, is make sure those cheek plates are in the right position, those roll seals are in the right position. It only would take a couple minutes if you have to adjust those and bring them a little tighter into tolerance to prevent some larger material from going over or around the rolls. Now to talk a little bit about your incoming product, because what comes into your machine is also going to affect what goes out of your machine. And again, I'll say I talk about corn here just because the majority of you are grinding corn. However, a lot of these principles do apply to about anything you're grinding. Just keep in mind that whatever your product is, in this case, I'm going to talk about corn. Not all corn is the same. Not all salt is the same. Not all limestone is the same. Soybeans are not all the same. So even the field you're getting your product from may be different from one day to the next. So you may see some differences in your machine, and it could also very well be attributed to your incoming product. Moisture is a very big variable we need to look at. For those of you that are grinding corn, and if there's any commodity buyers on here, please pay attention. 14% corn mixed with 18% corn does not equal 16% corn. Mixing them like that, I know the math works that way, but that's not how it really works. For most products we see, for every 1% we increase in moisture, we'll typically see a 10 to 15% loss in efficiency of that machine. So that's something to keep in mind if you are getting some higher moisture material is, hey, you might be able to buy it a little cheaper. However, you may more than pay for that in just the energy consumption to process that material. Another variable often overlooked is the temperature of the material. I did some testing on corn where we ran it at 0 degrees Fahrenheit as compared to 80 degrees Fahrenheit, and we saw about a 20% difference in the energy consumption. So keeping in mind for some of you that do get to the joy of experiencing all 4 seasons of the year, how you run in February may be completely different from how you are able to run in August. So just keeping in mind that ambient temperature as well will affect the incoming product. Now to talk real quick on the sampling method. Some of you might have been on my hammer mill webinar. I went over this as well. It doesn't actually change the performance of your roller mill or roll crusher, but it does change your perception of how you're grinding. So Julia at Kansas State did a real nice paper on describing the effectiveness and the differences of some of the variables you can use when performing a sieve test. Without going into a lot of details, it's basically saying make sure you're sampling the same way every day and you're always comparing apples to apples. If person A gets a sample from one place and person B gets a sample from a completely different place, there's a chance that data may be skewed. Or even if you're trying to compare what you're grinding to one of your other facilities or even a competitor down the road, making sure you're even performing the test the same way is what we need to make sure we're doing. Just because if you're not comparing apples to apples, it will be very difficult to understand what you're doing or what they're doing. Now, just a few general operation points to go through. A lot of these are pretty quick and easy ones, so I didn't want to have a whole lot of different slides for them, but one is the flow director inside of your machine. Again, this is when it's set at the factory. When we commission it, it's set, but over the years, especially some of you that have been operating your machine for 30 plus years, it's possible it's been moved. And what it is, it's kind of a little difficult to see in this picture, but it is this yellow flow director shown. It runs the width of the rolls, and this is designed to take the feed from the feeder and direct it right down into the top nip of the rolls. We want it directed right into the roll nip. That for efficiency, that way it's going straight in. It doesn't have to bounce around all over the top of the rolls. And also B, that reduces the wear on the rolls, because instead of just jumping all over and wearing the corrugations unevenly, it's going straight into the rolls where we want it. So making sure these are set, they are adjustable. Typically what you do is adjust them when you change your rolls, but making sure that they are set to go straight down into the nip. It's possible if you got an oversized material or some foreign material in there, it could have moved those. There we go. So for most of you that have a feeder on your machine, this is another very important area to look. Hopefully you're all cleaning your magnets frequently. And I see hopefully none of you have a confused look on your face wondering where your magnet's at. If you have that look on your face, we need to have a discussion. Please make sure you're checking them frequently, and not only checking them, you're cleaning them frequently. These magnets are only effective if they're clean and can capture more material. But on top of that, we also should be inspecting our feeder. We want to make sure that feeder can do its job and evenly distribute the material across the width of the rolls. If you have some damage like it's shown on the right picture, what that could do is, and that's a relatively small hole in there, but that's going to allow material to free fall and cascade right through that. And what you're going to see on that particular machine is where right below where that roll is, you may see some increased wear because the material is not being metered into it. So this is again why I say when you open up and you're looking at your rolls, if you see some abnormal wear or increased wear in one spot, there's a chance you may have a problem up above. Or on the opposite end, it could be if you have some sort of blockage up in your feeder and there's a couple inch gap where you're not getting any feed to, you're not going to wear that part of the roll, but you'll wear the other part of the roll. So inspecting your feeder to make sure you're getting good even flow across the whole width of the machine is very important. Now, I talked how I'll point out a few areas on your machine and where you need to look to make some adjustments. This is for those of you that are running the 900 or 999 series. There's a spring protection here that does allow, if you do get a slightly oversized, rock or stone or maybe a bolt, there is some protection to pop those rolls out to hopefully let it pass. Can't get too large, but that's where that spring is. Here's your eccentric that you're able to adjust your rolls with. And then if you do need to adjust the tram on our 900, you would use shims underneath this bearing or on the other side. That's where that's located. Your roll stops are this plate that's sitting on this rod, and there you'd have a threaded rod coming out of the front of your machine. And then if you need to adjust the parallel, you would be using these threaded rods here. If you heard me mention those that are running the 1000 or larger series, it's very easy for them on the outside of the machine. Unfortunately, for those of you with the 900, it is here on the inside. I understand your pain, but that is how this machine is set up. And then for this shows our 1200 series. It's very, very similar to all the other models. But when we talked about the roll tram, you might be able to see it. Hopefully you can. There is a bolt here right below the bearing. And that's what we're going to use that bolt to move that bearing up or down as needed to ensure that we do have our rolls and tram. Again, this is going to be done hopefully when you're changing out your rolls is when you would set that. The springs on this machine, you can see are right behind this roll here. Again, if you do get a stone or a bolt, it'll hopefully pop open those rolls to let that larger ungrindable product pass. And then I do show the jacks over here. I won't go into a lot of details there since we've covered that already. We talked a little about the roll stops. I showed it where it was on the 900 series. These are where they are on the 1000 or larger series. Hopefully most of you are familiar with how these are, where they are and how they're set. If you're not, the way it works is we have your stop collar, which is your course adjustment that's seen here. It's the inside collar. And what it does is as this threaded rod is moving in with the roll, once the stop collar meets this collar here, that will, I'm sorry, I'm not using the laser. That's my bad. All right, let's go over this again. So right here, the inside collar is your stop collar or the course adjust. Once this threaded rod is moving in with the roll and it comes into contact with this larger collar, it's going to stop and prevent that roll from coming in any closer. So that we use this collar to make sure you don't run your rolls together, which will help protect your investment. We don't want to have metal to metal contact that will wear those rolls much faster than you want to do. And again, you'd have to recorrugate your rolls sooner, which is going to cost you more money than you would like to. So making sure these stop collars are properly set is also very important, just so you don't have a new operator or someone go out there and just not know what they're doing and run those rolls together. Now, bearings are another very key feature of these machines. Those bearings are designed to last the life of the rolls. I should say they're typically designed. You may have some applications where they're much more harder on them, but for the most part, those bearings are designed to last the life of the rolls. So please make sure you are reading your manual and you are properly greasing them and maintaining them. Now to talk about belts a little bit. I know this happens every so often. We get a few calls on it, but if any of you are experiencing broken belts, there's a few questions we'd want to ask to help identify why you are breaking belts. You know, it's an annoying thing to have to do. You lose some production when the machine turns off. So the quicker we can get to understanding why those belts are breaking, the better. So these are the questions we ask if someone calls in with one of these issues. Is first and foremost, was it on the main drive side or was it on the inner roll drive? That already will start to tell us what could be the issue. Also really important is if you have multiple sets of rolls, is what set of rolls did it happen on, top, middle, bottom? And then how did the belts break? Did it look like they were stretched, kind of burned off, which, you know, could be a result of the shivs that are not aligned, you didn't have them properly tensioned, or even you put something in the rolls that shouldn't have been in there, or even if they looks like they snapped, which could be from a shock load, or if you had the belts too tight. So that's kind of the flow chart we'll go through if we do hear someone with broken belts. So just some things to keep in mind. That way, if you do need to reach out for help, these are going to be the questions we're going to ask you. So having some of this information ready to go will greatly help us help you. Now, in regards to belt tension, to talk about the main drive side a little bit, making sure they are properly tensioned and aligned is very important. So alignment on those shivs, really key. And then tension's also just as important. And the way we need to set them is it's 1/64th an inch of deflection for every 1 inch of span between the shivs. For a good majority of you that are listening, that's going to be about 15, 16, 7-inch deflection at about 14 to 17 pounds. You all should have been sent one of these belt tension testers when you bought your machine. Again, it's possible it may have gone missing, but this is what we use to measure your deflection and the tension on there. And to go to the IRD side, or the inter-roll drive side, we do have most of your machines were sent with a decal here with a ruler on it. And we want to see the front end of the cylinder be right about the 5 1/4 to 5 1/2 inch mark on that decal. Is typically where we want to see that machine set when you're in the operating and running position. And one other thing to keep in mind, if you do see right there on the far left, I have it circled in red, is if you do have the two nuts on there, please make sure you have this second nut all the way extended and not restricting the movement of the cylinder. You can see if we have it restricted, those springs are not able to do their job. One thing I did want to mention, I skipped over a little bit on the tram, I apologize, is all of those 1,000 or larger machines are all sent with a tram gauge that you can use on your machine as well. Usually they're painted red, but that is something you get with them. Now, another component that's, again, sometimes overlooked is just making sure that your feet are spinning the right direction. This should have been tackled and looked at during commissioning, but it's possible, again, things change if you had to change the drive or something. Making sure that that feeder is spinning so the product is discharging in front of that magnet. That way we're able to utilize the magnet. If you have the feeder spinning the opposite direction, it still will feed the material into your roll crusher. However, we're not able to utilize that magnet, so you're not going to be pulling out some of that foreign material that we like to keep out of the rolls. So just making sure it is spinning across the face of the magnet. Pretty simple item to check. Now, for those of you, this is going to be applicable to those that have multiple sets of rolls, whether it's a double pair or a triple pair machine. Making sure we're spreading the workload out evenly over those different pairs of rolls is very important. If you have one set of rolls set way too tight as compared to a different set, we're going to try to overgrind with one set of rolls, which will create premature wear on those corrugations while the other set of rolls is not doing much work. So making sure we're balancing out the workload over all sets of rolls is really important. You paid for those rolls, we want to make sure we're using them all evenly. So depending on your machine you have, there's a couple different ways we can do this. This triple pair shown here has 3 motors for 3 sets of rolls. So this would be very easy to monitor just because you can look at the amp load of each set of rolls, and that'll tell you pretty closely with what each pair is doing. Now, I understand that there's quite a few out there that have maybe our RM setup where there is 1 motor for 2 sets of rolls. And that's fine. We can still figure out what each set is doing. I put together just a little quick steps on how you can do it. It'll take a few minutes, but basically it just takes a little bit of math and you can figure it out. I'd be happy to work with you guys offline if we do want to go into this a little bit, but feel free to read. Basically, you're going to record some idle amps, some operating amps, and then you just have to open up the bottom set of rolls, and then you just compare the difference between them. And then we can figure out what each set of rolls is doing. And if you discover you're doing 80% of the work on one set of rolls, we're going to try to even those out a little bit just so that we can keep the roll wear the same. Because what could happen then is you might have completely worn the corrugations on one pair and not the other. So now you only have to pull out one pair of rolls to send in for recorrugation, and then you just kind of get everything off kilter. And we prefer to have you wear them at an even rate. And just to kind of give you a visual of what it is, obviously I went to art school to make this graphic, but you can see if you have too much material trying to go through the top set of rolls, which I'm showing on the right side, you're going to get a little buildup. And when you have buildup in those rolls, you're going to wear those corrugations faster than when you'd like to. And also, if you have it where you don't have the bottom rolls close enough, you may not be doing any or very much grinding at all in that bottom pair. So in this example over here on the right, we're going to wear the corrugations on these rolls much quicker than if we are even wearing the ones on the bottom. So we want to see it like we have here on the left. You want to see a nice curtain of material going through the machine so we can wear the rolls evenly. Another component to talk about, this one really doesn't affect the throughput of your machine at all, but it's the aspiration that we can put on your machine. These are a little different. For those of you that are familiar with hammer mills, we need that aspiration to help pull the material through the machine. However, on a roller mill, we're really keeping it for housekeeping. To keep the area in a little cleaner, but another really important part of the aspiration and pulling a little negative air off your machine is it does prevent some of that dust from getting into where your bearings are. Your bearings do have seals in them, but we try to keep that area as clean as possible. We don't want that material getting up into the bearing. So if you do have the option to put a little bit of aspiration, and your machine should look either like the one on the left or the right. If it's a newer machine, we have these full width aspiration ports. The one on the left may just have that little red cap. But if you do have the option to put some aspiration on it, I am a big proponent of it just from the standpoint of, like I said, it can help keep that room a little cleaner, don't have to push a broom as many times, but also that you can extend the life of those bearings, help prevent maybe a premature failure on that bearing. And then something I just kind of would like everyone to take away is, especially for those of you that have been around that machine for a long time, or if you're just starting to get familiar with your machine, is you learn what that machine sounds like under normal conditions, normal operation, and know what that sounds like. You know what the frequency kind of feels like, and if something doesn't sound right, that's a good time to stop, check, to open up the machine and try to figure out what it is. You can prevent a lot of headaches down the road with a little preventative maintenance. So if something doesn't sound right, I really encourage you guys to do a little investigation. Even hop on the phone with us and let's try to figure out what's going on. At the end of the day, to protect your investment is what we're after. So, and that goes in a little of just making sure you have all the right parts on hand. Do you have a spare set of rolls if something were to happen? Because the last thing we want to do is hear that you're down, and if you're not able to make your product, you're not going to make a whole lot of money. So what's your downtime cost you? Do you have the correct set of parts on there? It's don't want this presentation to be a sales presentation, like I said, but making sure you do have the correct parts on hand, that should something happen, you can get your machine back up and running as soon as possible to produce the product that you're selling, to make sure you are still making money. So that's what I had for you guys today. As we said at the beginning, we'll take a few questions. I know Tanner has been going through and jotting some down. We'll answer a handful of them. For many of you guys, I know if they're overly specific or we can't get to it today, we will follow up and make sure we do get all your questions answered. So feel free to ask as many as you'd like.
All right, Doug, we'll start off with, what is the useful life of a roll?
So one answer you guys may hear from me quite a bit today is it depends, but just to be general for everyone here, you can use about 10% of the diameter of that roll before we'd say you're past the hard facing of it to where you're getting that softer material in the core.
Okay, great. Another one's a little bit specific, so we can give some rough estimates on this and then reach out to the person directly. We are deholing yellow peas and run them through a roller mill to split the yellow peas to make split yellow peas. Can we use one of these machines for our application?
Let me think on that for just a second. Yes, I would think this would be an application we could look at. We should have your contact information. This will be something I'd like to take offline and have a further discussion with you on what we would look at using.
Great. And would the blue roll be available in a sawtooth cut, and can it be recorrugated by standard corrugation equipment?
Tanner, I actually will let
Do you
you
want me
take
to
that.
answer that one?
Yep, I will let
Yeah,
you do that one.
yep. So it does depend on the blue roll. The sawtooth is available, but we would have to look at what the corrugation is and how fine it is, and it would not be able to be recorrugated on standard equipment. We will follow up with you directly on this question.
And just so everyone knows, Tanner is our customer service manager and has been very prominent in the blue roll technology, which is the reason I had him answer that question.
Okay. We were getting some great questions about translating to different languages, so we will follow up with that. Another question is, can you use roller mills in post-grinding operations?
Yes, yeah, you can. There's be a certain challenge. There could be a few challenges to it depending on what you're doing. Um, One of the difficulties we see with that is you can sometimes see the material segregate a little when you're moving it around in your plant. So you can do it. I don't know of many that are doing it, um, but it is possible. There's just definitely some challenges and hurdles we'd have to overcome before we get the final product we want.
Okay, great. Another one is, how often do you need to change the rollers from the front to the back or vice versa?
So the rolls in your machine are very similar to kind of what you should be doing with your vehicle tires. When they come back in for recorrugation for us, one of the things we do is measure the diameter of the rolls, and we will take the roll with the largest diameter and we will put the coarsest corrugation into it, which will take the deepest cut out of it. So um, there's no specific answer, but making sure they are rotated around to make sure we are wearing them evenly is the most important thing. So it's something you want to keep an eye on when you are recorrugating them to check the diameter, and then you'll want to put the coarsest corrugation on the largest diameter roll.
Okay, one other question that I can answer right now is we had a couple of questions about doing field evals on these or field service. So we do have both service available and also Doug's application team available for on-site audits. Doug, do you want to dive any deeper into that?
I think you pretty well covered it. That is a service we offer. We're happy to do it. Come out and we'll go through all these checkpoints with you, show you what we're looking at, what we found, and even can do some trainings for your team on site. So no, I think you pretty well covered it.
Okay, and that service can be found on our website or by your local CPM rep. Okay. So here's a question: when to use a hammer mill or a roller mill?
Ooh, that's a great question, actually. That really depends on the product you're grinding, what you're looking to get for a final grind, as well as what your energy requirements are. We'd probably even want to look at what you're paying for electricity, how tight of a standard deviation you're looking for. There's a lot of questions we'd want to ask, so I can't give you a specific answer, but I'd be happy to have that conversation with you offline.
Okay, and a question about a scalper above a roller mill. Can you basically speak on the use of a scalper above a roller mill?
Anything you can do to pull out any foreign material prior to the roller mill is beneficial. As I kind of mentioned, uh, that roller mill was designed to grind your product and only your product. So if we're talking corn, I understand you get little pieces of cob in there, you might get some stalks in there. And for the most part, you may not notice that too much, but that foreign material is going to wear your rolls differently than the product it's intending to grind. So if you are getting material in there that we don't want, you might see some premature wear. So I'm a big proponent of anything you can do to pull out that foreign material as much as you can beforehand is well worth it. So I am a big proponent of doing whatever we need to do to pull material out in front of the roller mill.
Okay, we are getting some great questions in. Um, so here's, I'm going to combine two questions together for you. Can we replace the hammer mill with a roller mill? And compared to the hammer mill particle size distribution, is it wider or smaller?
First answer, it depends. However, so depending on how fine you're grinding, yes, it is very possible to replace a hammer mill with a roller mill. I've done it many times for people all over the world. A couple advantages there is a lot of times there's an energy savings, and typically for most grinds, we will have a tighter standard deviation when we're using a roller mill as compared to a hammer mill. Again, without knowing your exact application, it's hard to say, but typically, yes, we see some more benefits. And it really is going to come down to how fine you're wanting to grind. Just in general, roller mills and roll crushers are much more energy efficient machines than hammer mills are. However, that roll crusher or roller mill typically cannot grind as fine as a hammer mill can. So that's kind of where your trade-off is. And actually, if you are running a hammer mill, one thing we can actually look at doing, and this would be a whole nother conversation, is installing a roller mill in front of your hammer mill. We can do a little bit of a pre-break before we get into the hammer mill, and we can improve the efficiency of your machine. But don't want to get into a whole lot of those details now. Again, I'd be happy to have that conversation offline with you.
Great. How important is the feeding of the product on the roller?
Very important. Kind of like I mentioned, if you have a 36-inch wide machine, but you're only feeding 20 inches of it, you're only going to use a little over half of that machine. So you're wasting a lot of the investment you made. And not only that, if you're not feeding the entire width of the machine, you're only going to wear half of the machine. A crude example would be, on your vehicle, most of you have four tires. If for whatever reason you're able to do it and only drive on the two right tires of your vehicle, you're only going to wear those two right tires. But when you go to change tires, you have to change all four. So you paid for four tires, but you only use two of them. So we want to make sure you're using the entire machine you bought.
When a roll is recorrugated, can you change the corrugation?
Yes, absolutely we can. That's the process we use and recommend, where when it comes in, we want to lathe those corrugations back down to smooth, and then we can put whatever corrugation we want onto it, which is why I kind of mentioned we will put the coarsest corrugation on the largest diameter. We do not trace over the corrugations because as you lose some of that diameter, it's actually mathematically impossible for all those corrugations to perfectly line up. So yes, you can change the corrugation, which is again one of the reasons I said if you are sending your rolls in for corrugation and you've just been doing it that way for years, decades, please feel free to ask. We might have a better option for you that could improve your process.
How often should a preventative maintenance schedule be done?
I can't give you a straight answer. The more often you check that machine and look at it, the better. I mean, I understand you have limitations to how many people you can have on site and you're paying for and have time for, but if it were up to me, I would like to have a guy sitting there 24/7, keeping an eye on that machine. I understand that's not feasible, so as often as you can.
All right. Can you use one machine for two grinds by stacking them?
Not exactly sure the angle you're coming from here, but theoretically, yes. And I know that's something we have offered many years and decades ago where, we could run, if you're looking for like a coarse grind, let's say, we could run product A through the top set of rolls and have the bottom rolls wide open. And then if you want to run product B, we could open up the top rolls and then run them, have the bottom set of rolls designed for that product. So absolutely yes, if that's the angle you're going for, it's certainly something we can look to set up that way.
Okay. I think there's a couple more, and there are quite a few specific questions coming in that we will follow up on these questions to you. In general, how many recorrugations can you perform on a roll?
Oh, well, again, it depends on the depth of that corrugation and the coarseness, but 4 to 8 is kind of a good rule of thumb.
Yep. And depending on how fine, if it's a fine corrugation like 14 to 18, you might be able to get more than that. Okay. I think that is it. Again, we will follow up with the more specific questions after the webinar.
So actually, Tanner, I'm going to jump in and take one more. I just thought come in here asking what a reasonable standard deviation is for a double pair machine at 700 to 800 microns. This gets in a little to what I talked about with Julia's work at Kansas State, where my answer may be completely different from another lab that runs a sieve test just based on how I perform that test. In general, typically I would say you could expect 2.0 to 2.5. You might see it a little lower or higher just depending on how that test is performed, because that's very crucial, like I said, as to where's the sample pulled and, if you're using any sieving agents or dispersing agents. So, but if you want a rough number, 2.0 to 2.5.
Okay, a lot of questions about a copy of the presentation.
So yes, everyone who registered for this webinar, whether or not you attended, obviously if you're listening to us, you are attending, but you will all receive a email in about an hour or two. That's a follow-up that will have a copy of the recording. So you'll be free to listen to it again or share it with all your family and friends or coworkers.
Okay, I think that's it, Doug. Unless you pull out anything else from the questions, I think we can wrap it up, and a great webinar.
Awesome. Well, I appreciate everyone's time. My contact information is right here on the screen. You're always welcome to reach out to us with any questions you may have, or if you have any suggestions for any future webinars, please feel free to drop us an idea, and we're happy to look into it.